Welcome back to Empowering Introductory Algebra, the informative series created to assist students to build a strong basic algebra foundation leading to those college-level studies. Hi, I'm Bob Young, Assistant Professor of Mathematics at Brevard Community College. With the help of the great support staff of WBCC, we continue to bring you introductory algebra lessons containing notes, graphics, tons of examples, and study tips. Let's pick up where we left off in our last lesson. Now, if you remember, we've been discussing polynomials the last several lessons, and we've talked about many aspects of polynomials. One, we've talked about power rules, the 5 essential power rules for polynomials. We've classified polynomials according to whether they're binomials or monomials or trinomials. And we've talked about the degree of polynomials. We've talked about coefficients, adding, subtracting, multiplying polynomials, foiling, all types of fun things with polynomials. So today, we're going to go ahead and start where we left off. We're going to go to the graphic on division of polynomials, because this is one I wanted to make sure you have in your notes. Division of polynomials, now remember, and we've already discussed this in the previous lesson, to divide a polynomial by a monomial, divide each term by the monomial. Divide the coefficients, now that's the numbers in front, and use the power rules to divide the variables. So going to the examples we've looked at already, when we divide monomial into a monomial, we just take the numbers -2 into 16, we got -8, and on the variables, remember, whenever you divide same bases, you subtract the power. So 9 minus 4 gave us the -8x to the 5th. And similar to the next example here, number into number, +4, subtract the powers on the p and q, p11, q3. So these were examples of, again, monomial division. And then we went to some more sophisticated examples, and I can kind of cover these up with my fingers here. We went to a trinomial on top, divided by a monomial, and we said the best way to do that is to go ahead and write that monomial underneath each term, and then just take them one term at a time. And again, we divided number into number, and we subtracted the powers on the same bases there. So x to the third divided by x gives us x squared. And then we got our answer going across, and we did this example as well in the prior lesson. We began the next with long division of polynomials. Now that's division by more than one term, so this is kind of where we got left off in the middle of our last lesson, so this is where we're going to pick it up. And I want to go to the graphic on this as well. So let's look at this graphic. Division of polynomials, long division. And now notice it says arrange all polynomials in descending order of powers, skipping no powers, and that's very important. And the steps there, the 4 steps: 1, divide first term into first term. Step 2, multiply. Step 3, subtract. And notice after subtract, I've got a little saying here that I use, and I've seen Dr. Argo use this as well in lessons on in the classes that he's taught. So he says draw the line and change the signs as only as Dr. Argo can say it, but I'm going to throw in the word boldly change the signs on that step 3. Draw the line and boldly change the signs. Boldly go where no man has gone before. And step 4, bring down the necessary number of terms. So let's go back to some examples, and we'll show you and illustrate those 4 steps for you. Notice here we have a binomial divided into a trinomial. So I went ahead and took the bottom term and divided it into the top term. Notice we're not skipping any powers here on any of the polynomials. This is x to the second, x to the first, and then the number, x to the 0 power we don't write. So this is in nice descending order, terms we've used in the past. And the binomial also goes from x to the first power to the number. So what we do when we divide more than one thing into these long strings is we take this first term x into x squared goes x times. Okay, so what do we do with these two things now? Step 2 on the graphic said multiply. So we're going to take the x, and if you want to, you can bring that step over here on the side. X times x plus 2, we can write that result right underneath here. It gives us x squared plus 2x. So notice there's some things in the past here important, distributing. Now, what I mean with this now, you have to subtract this whole binomial here you just got from this trinomial up here. So when you subtract, remember, this is where we use the term draw the line and boldly change the sign. So this becomes a minus x squared, this plus 2x, and see that plus sign there? Watch this plus sign, what I'm going to do to it. Get rid of it. And boldly make that a minus sign so you know you change them. All right, so if you long divide and do it right, what happens is the x squares now do what? Yes, they go out, and then you can bring down the x's. Now, how many x's? That's a positive 5 subtract 2, positive 3x. Now, what you need to do next is to bring down this plus 6 on the end, see, because we're dividing by two things out here, so we need to have two things down here to go into it. So I'm going to bring that plus 6 down, and some of you may recognize when you divided regular numbers back in basic math, the same concept holds. Okay, so we take the first term now in the x plus 2x, goes into this 3x how many times? Well, it would go 3 times. And if you didn't see that, you could come over on the side of your paper and write it like this if you wanted to. 3x divided by x, and the x's would cancel out, leaving you with plus 3 there. All right, now what do I do with the 3, Young? Well, we're going to take the 3 and multiply it by the x plus 2, put that result under here, and you can show that step here. Actually, I had a student tell me to do this one time, and I listened to you students out there. I thought it was a great advice from a student to go ahead and write that step so you see where this comes from. So multiplying, we're going to get 3x plus 6. Now, what do I have to do with this 3x plus 6? Well, I have to subtract it. So there's the old draw the line and boldly change the sign. So when you subtract more than one thing here, remember, when you subtract polynomials, the signs will change on all the terms. So notice you know you're going the right direction. The 3x's go out, and in this case, the 6 goes out, and you're left with no remainder. So the final answer, when we take x plus 2 into x squared plus 5x plus 6, will be x plus 3. All right, now how can I check that, Young? I'm not sure that's the right answer. Well, what checks division? How about multiplication? If we took the x plus 2 here and multiplied it by the x plus 3, what process would that be? There's our friend FOIL from previous lessons. So if we FOILed this, x times x, we would get x squared. The outside two terms, so these are going to be our rainbow numbers, 3x plus the inside two terms, 2x. Adding those together gives us the 5x back. And the last two terms, the 2 times 3 gives us 6. It indeed does check. So life is good. All right, let's do some more examples. Now, if you didn't get it with that one, don't panic. I'm not just going to leave you hanging with one example. You know the old BCC network here. We give you a whole bunch of examples to go with. So notice I even tried to make this one a little scarier. A binomial into 4 terms. Oh, Young. Oh, yeah, so don't panic. What you do, same principle. First term, 4y, goes into 12y to the third how many times? Well, 4 goes into 12 3 times. Y goes into y to the third how many times? Y squared. All right, so now what do I do with that once I take first term into first term? Well, you're going to multiply, step 2. So I'm going to take that 3y squared times the 4y plus 3, multiply it, write that result underneath here. So distributing the 3y squared through, I'm going to get 12y to the third power plus 9y squared. And what do I do with this? Subtract it from what's up here. So to subtract polynomials, remember, draw the line and boldly change the signs. And you know you're doing it right because the y cubes just went toodles. They went bye-bye. How many y squares come down? Well, you have a negative 11 and a negative 9, or subtract 9. Same signs, add the numbers, put the sign. You get a negative 20, y squared comes down. And remember, you're dividing by two things here, so you need to bring that 9y down. And make sure you always have, when you're dividing by two things down here. All right, so keep going, same process. 4y goes into negative 20y squared how many times? 4 goes into a negative 20, a negative 5. Y goes into y squared, y times. So something else to note here for students, notice that if my polynomial is arranged in descending order of powers correctly, skipping no powers, as we mentioned in the graphic, my answer is in nice descending order. So that works out pretty well. So now I'm going to take the minus 5y and go ahead and multiply it by what's out here, the 4y plus 3, and I'm going to write that result under here. Minus 5y times 4y minus 20y squared, minus 5y times 3 minus 15y. Now what do I do with this? Subtract, yes. Draw the line and boldly, boldly, boldly change the sign. So notice both of those minuses became plus. I know I'm doing it right because the y squares just went toodles. All right, how many y's we bringing down, Young? 9 and 15, last time I checked. 24y, and then I need to bring this 17 down. Now this is when students ask me, Young, when do we know we're done? Well, when you get to this last number down here, you're done. Stick a fork in it. All right, so first term into first term. How many times does 4y go into 24y? And yes, that would be up top here, a plus 6. So boy, this is a nice long one. Notice I've stretched it out. I only have one problem per page on when it gets tougher here. So we'll take that 6 and multiply it through the 4y plus 3, and we end up with 24y plus 18. Okay, draw the line, subtract, boldly, boldly, boldly change the signs. So in this case, I have a remainder. I know I'm doing it right because my y's canceled out, and I have here a remainder of plus 17 minus 18 is a remainder of a minus 1. And you can write that several different ways. What I like to do is whenever I have a remainder, I just go ahead and put it up here plus negative 1 over what you're dividing by. So whenever you had a remainder, remember in basic math, you always took it and put it over what you were dividing by, and the rules for polynomials hold the same. So there is your answer to this long division. I think some of you out in the audience can appreciate why they call this long. Yeah. All right, one more of these. Now again, some of you may have said, oh, I got a little better on that one, Young, but I want to make sure I've got this real well, so I threw one more at you here. And notice this one I put skipping some powers. Yeah, all right. So what we're going to do here is we're going to make our long division bar. And I'm going to go ahead and write this underneath here. Now some of you said, well, that's a pretty long division bar just for those 3 terms, Young. But watch what happens here. The a to the 4th power is going to go first. And they skip from a to the 4th to a squared. Those dirty rats. So what we're going to do is we're going to go ahead and not skip. We're going to put an a to the 3rd power in here so we have things lining up. Now, you know how many a to the 3rd power? Some of you out there are probably saying, but Young, I don't see any a to the 3rd powers in here. And that's what I'm going to write here. You're exactly right. There are no a to the 3rd power, so I'm just going to go ahead and put 0 up. Is that all right with y'all? Oh, I don't care if it is or not. We're going to go on anyway. All right, and then we're going to bring down the a squared, so we'll have minus 3a squared. And then they go from a squared to the number, they skip the poor a's. So I'm going to go ahead and put plus 0a here, and then plus 7. All right, so now we have this polynomial, which is a trinomial, all arranged in descending order of powers, skipping no powers. So don't skip them. All right, now notice what we're dividing by also skips a power. It goes from a squared to the number, so we're going to go ahead and insert plus 0a in here. All right, so now we have this polynomial. A lot of students don't even realize that none of the polynomials can skip powers here, and if they do, boy, you can get in trouble. Now, what this does for you, it lines things up so nicely. Watch what happens now. So we'll go back like we did all the other ones. A squared goes into a to the 4th how many times? And like I said, if you're not sure, come over here on the side of your paper and write it like this. A4 over A2. What do I do with the powers? I'm dividing same bases. You know what? Subtract. So we get a to the 4th divided by a squared is a squared. Multiply. Take the a squared, and we'll run it through this trinomial here. And you know what we're going to do with that, right? We're going to write that result right underneath here. So a squared times a squared gives us a to the 4th power. A squared times 0. Now remember, anytime you hit something with 0 there, you can write this plus 0a to the third. It's still going to be 0. A squared times a minus 1 gives us a minus 1a squared. Now again, if you want to put the 1 there, you can. What am I going to do with all this from previous examples? Subtract. Draw the line and boldly, 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 on 0 here it doesn't matter, change the signs. Doesn't matter if you say plus or minus 0, does it? All right, so what happens? A fours, gone. A thirds, well, 0 and 0, gone. How many a squares coming down? We've got negative 3 on top here, plus what here? Young, I don't see a number in front of that a squared. Remember, you can put 1. Negative 3 plus 1 is a negative 2a squared. So that's what comes down from this, negative 2a squared. Now, how many things am I dividing by in this problem? Well, I've got 3 up here now, so I want to make sure I have 3 things down here to match up with these 3 things. So it's always important to know how many things you're dividing by so you can line things up. So I'm going to go ahead and bring down not only the 0a there, but the plus 7 as well. All right, so notice how nice this is arranging here. So a squared goes into a minus 2a squared here. First term into first term, how many times? Well, it would be, yes, a minus 2 times. So I can take that minus 2 and multiply it through here. And I'll end up with minus 2a squared. Negative 2 times 0 here is still going to get me 0. So it doesn't matter if I put plus or minus 0 here. It's just going to 0 out. And then what kind of 2? Watch your signs. Again, sign errors can get you negative times negative, positive 2. Okay, subtract. Draw the line. Now again, when you subtract something that's negative, it becomes what? When you subtract all this, the negative becomes, so subtracting a negative is positive. All right, so that's why you do this. Draw the line and boldly change the signs. All right, so I don't want to miss anything. So notice if it's a plus in there, I wipe it out. I put that minus sign so I don't miss anything. So be careful. So the 2a squares go out. I know I'm looking good. The a's in this case go out, bringing me down to the numbers, which is going to total 5. So that's my remainder. Now, how do you write the remainder again, Young? Well, in this case, it's a plus 5, so I'm just going to write plus. I always put a plus here, whether it's plus or minus remainder. And then I just put whatever number or remainder there is in the numerator here, and then what we're dividing by was the a squared minus 1. Not necessary to put the 0a back there. All right, so 3 long division examples, all of different nature. So hopefully you're getting a good feel for these now so you can go and practice some on your own.